Welcome to Informatica Cloud 201 on-demand course, Hierarchical Connectivity, the REST Web Services. After completion of this module, you will be able to understand the types of web services supported in the Informatica Cloud platform with more focus on the RESTful web services. Use the REST connector to connect to the applications exposed via the REST web services. Compare JSON and XML response messages. Build a DSS that connects to OpenWeather using the RESTful web services and return data. First, let us understand what are web services. A web service is a collection of open protocols and standards used for exchanging data between applications or systems. It is a service that is available via standard web protocols such as HTTP, SOAP, etc. Web services are a set of tools that can be used in a number of ways. The three most common styles of use are XML over HTTP, SOAP, and REST. Web services use the transport protocols for transporting messages between the networked applications. It includes protocols such as HTTP, SMTP, FTP, etc. HTTP is transport protocol used to send data. It is used by World Wide Web and is the most commonly used transport protocol. Next, you need to understand what is a payload. To understand the functioning of the web service, in a broad sense, payload is actually the content of the message that you're sending using the transport protocol. In most of the web services, the payload is an XML format. You can also find different types of XML messages. Atom is an agreement of XML with certain tags in it. It's a standard way of describing the data. Other examples of payload XMLs are MIME or multi-purpose Internet Mail extensions, which is used for transport of multimedia information via asynchronous Internet mail. Binary files, which can be base64 encoded, or text, which are used as payloads for FTP transfer. Another type of payload used is JSON, which is a non-XML type payload. JSON stands for JavaScript Object Notation. It is a self-describing language like XML, which is newer, lightweight, and consumes less data to send, and hence it is faster. It is currently not supported in Informatica Power Center, which is one important reason to use Informatica Cloud. Now, let us see why do we need these web services. Take a look at these systems. These systems could be created by a different set of people who may or may not be there in the organization all the time. These people may have used various approaches to create these systems. These systems could be known or semi-structured systems. Without web services, you will need to build point-to-point data integrations between all these systems. In such type of setup, if something breaks or is needed to be fixed, you're not sure on what needs to be done. At the end, it may become a complex riddle because you don't know the technology that was used for setting these systems. So in such situations, web services functionality can be used. Web services are open standard-based web applications that interact with other web applications for exchanging the data. Web services can convert your existing applications into web applications. Web services allow structured datasets. Structured datasets are organized and lets you access everything in the same way. As per ZapThink, 70% of IT development budgets are spent on integrating different systems. Web services provide interfaces based on industry standards using which you can access and integrate systems very easily. Web services are use case based as opposed to the point-to-point solutions. The more systems you have, the more you need to integrate them. Now let us discuss the different types of web services available. There are three types of web services: REST, SOAP, and XML over HTTP. Let us discuss each of these in detail. REST, which is also known as Representational State Transfer, or RESTing, or RESTful Web Service. In the REST architectural style, data and functionality are considered resources and are accessed using Uniform Resource Identifiers, or URIs, which are also commonly known as URLs. In REST, in the query string of the URL, you type in command with the data that you want to send to the web service and get back a response in XML or JSON format. These web services are simple and easy to test. SOAP stands for Simple Object Access Protocol. It is a standard protocol used for message exchange between web service and client in XML format. All the SOAP web services require a WSDL, or Web Services Description Language. It is an XML file that describes the technical details of how to implement a web service. The SOAP web services are complicated and therefore require WSDL to describe them. These web services are too difficult to manage manually, and hence you use WSDL to generate code for them. The SOAP web services are of two types: RPC encoded and document style. RPC encoded is procedural in nature, which means it asks for data by the name of the procedure and for certain data types. For example, give me account details of customer since this given date. Document style indicates that the SOAP body contains an XML document which can be validated against a predefined XML schema document. An XML message is created that contains all the required information. You send the request and get the response in XML format. XML over HTTP is the third type of web service that uses XML over HTTP. In this case, XML is posted over HTTP to access the web service resources and return the response in XML. REST was first introduced by Roy Fielding in the year 2000. REST is an acronym for Representational State Transfer. It is a web standards-based architecture and uses the HTTP protocol for data communication. It revolves around resources. Every component of a REST web service is a resource, and the resource can be accessed by a common interface using the HTTP standard methods like GET, POST, PUT, or DELETE. Hence, if you need to access the resource, you send messages or requests to the server that contains the resource. Each message consists of an endpoint URL, type of operation to be performed, the request header, and the request body. Now that you understand what is a REST web service, let us now discuss what are the different parameters of a RESTful web service request message. URL. Each resource in the REST architecture is identified by its URI, also commonly known as URL. The purpose of a URI or a URL is to locate a resource on the server hosting the web service. You can pass the parameters in the URL which can be used to process the request. Such parameters are known as URL request parameters. Method or verb represents the HTTP operation that is to be performed, whether GET, POST, PUT, or DELETE. Header contains metadata for the HTTP request message as key value pairs. For example, client or browser type, format supported by client, format of the message body, and cache settings, etc. In order to process a request, you may pass the parameters in the header section of the request. Such parameters are known as header request parameters. Body is the actual message content. In a RESTful service, the representations of resources sit in the body of a message. You may pass the parameters through the body as well. Such parameters are also known as form request parameters. This example shows a REST request message in XML format. The first line shows the HTTP method used in the request, which is GET, and the endpoint URL. The complete XML payload message starts from the next line. This message is processed to retrieve all the bookmarks and tags of a given user. Let us now discuss the details of the REST Web Service response. The REST Web Service response is an HTTP response containing two parts: response header, which contains the metadata for the HTTP response message as the key value pairs. For example, content length, content type, response date, server type, etc. Response body, which is the actual content of the response message. This message can be in XML or JSON format, JSON being the most common type of format. Let us now discuss what services or protocol fit inside a web service. XML or JSON in the payload. XML is the most common for SOAP. JSON is used only for the REST web services. The reason that XML and JSON are used as a payload is because the data is self-describing. You can thus send the whole payload to the target system and it would understand the request you're looking for. SOAP and REST, these are the message formats or different representations of a web service. Transport Protocol, HTTP, SMTP, POP3, IMAP, FTP, Telnet, Gopher. These are various standard protocols used for data exchange, out of which HTTP is the most commonly used protocol used by the web services. When you need to read data from or write data to another endpoint in Informatica Cloud, you must first find out what kind of web service it is, what are its inputs and its outputs, and what components in PowerCenter will be used to convert the data into rows and columns. These questions will help you understand how to connect to other endpoints via the web service. Let us now consider the Twitter API example to demonstrate how, using the REST API, you can send a request and receive response in the JSON format. As you can see, the highlighted text represents the query string. The query string contains the input to the web service, which is used to process the data and return the response. In most of the cases, the REST API returns response in the JSON format. JSON is lightweight and transfers less information about the data being transferred over the Internet. This provides better security to data transfer, and hence JSON is preferred over XML. Note, the advantage of using Informatica Cloud is that it supports response in the JSON format, which is not yet supported by the PowerCenter. The REST web services can return response in XML or JSON format. Let us discuss the pros and cons of a REST web service returning the XML response. The pros are as follows. It's lightweight, easy to understand, and easy to test by humans. However, there are some cons too. They are not flexible and hence it is harder to generate code from a RESTful web service if the HTTP returns response in the XML format. Some example applications are LinkedIn, Twitter, Facebook, etc. Now that we have discussed the RESTful web service where the response is returned in XML, Let us try to understand the basic difference between response returned in XML versus the response returned in JSON. JSON is extremely lightweight XML. On the contrary, it is extremely verbose. It is used very commonly in JavaScript-enabled web clients, while XML is better suited for Adobe Flash, Oracle ADF, Microsoft InfoPath, or open-source solutions such as NetBeans. JSON deals well with atomic values or lists or hashes of atomic values. On the other hand, XML deals well with extremely complex unstructured data. JSON is better for schema-less and entity-free data, while XML is better suited for namespaced, well-formed, mixed-content documents. Let us now discuss media, request, and authentication types supported by the REST connector. The REST connector supports application XML, application JSON, text WML, text plain, and application XWW form URL encoded media types. Media types treat the body of an HTTP request or response as part of an application-specific interaction. So if the media type is application XML, the header simply tells the client that it should expect some XML formatted text. Similarly, if the media type is application JSON, the header simply tells the client that it should expect some JSON formatted text. Of these, application XML and application JSON are widely used. REST supports 4 request types. The GET-REQUEST type requests are used only to read data and not to change it. Therefore, when GET is used this way, it is considered safe. That is, they can be called without risk of data modification. Additionally, GET is idempotent, which means that making multiple identical requests end up having the same result as a single request. The next type is POST, which most often utilizes to create new resources. In particular, it is used to create subordinate resources, that is, subordinate to some other resource. PUT is another type of request which is most often utilized for update capabilities. PUT puts a file or resource at a specific URI and exactly at that URI. If there is already a file or resource at that URI, PUT replaces that file or resource. If there is no file or resource there, PUT creates one. The last request type supported by the REST connector is delete, which is used to delete a resource identified by a URI. REST supports the following authentication types. Non-auth. No username and password is required. Basic auth. It's the HTTP basic authentication which is based on a username and a password. Digest auth. It authenticates a user based on a username and a password. However, the authentication is performed by transmitting the password in an encrypted form, which is much more secure than the simple base64 encoding used by the basic authentication. OAuth. OAuth is an open standard for authorization commonly used as a way of Internet users to log in to the third-party websites using their Google, Facebook, Microsoft, Twitter, One Network, etc. accounts without exposing their passwords. To optimize the connector functionality effectively, you need to follow the given recommendations. In case you like to fetch data using a query string in the URL, you can fetch data based on the single parameter mentioned in the query string. For a list of parameters, you could use URL input parameters config file, form request parameters config file, and header request parameters config file. It is recommended to give the URL request parameter, form request parameters, and header request parameters should be such that it fetches maximum data from the REST endpoint server. This allows the connector to analyze and store more metadata. Use the JSON-based response as it is proven to be more stable when the same endpoint supports both XML and JSON-based responses. You should use the sample response XML or JSON file field to manually control the metadata. Any manual change in the file will change the list of tables or records or the fields once you click Refresh Fields. Let us now discuss the best practices for using a REST connector. Ensure that you have the correct authentication. You could use your browser to test your authentication is correct. If there is a choice between XML or JSON, choose JSON for obvious reasons we have discussed previously. To manually control the metadata, fill in the sample response XML or JSON file field in the connection parameter. Upon receiving the response, you can download the raw response data from the REST web service into a separate folder. The raw data would help you understand whether the response is minified or not. Let us assume that you're using the Informatica Cloud and you want to utilize a RESTful service that is exposed to acquire weather data for analysis by the business. Here, you will create a DSS task that will consume the REST web services and pass data through filters and receive JSON message format. This message will then be parsed through the connector into a CSV format. Here, we are using the OpenWeather API to fetch the weather details for a city. In order to access the API, you need to sign up for an API key to make successful REST calls. In order to get the API key, first you need to register on the sign-up page by entering the URL. Enter the username, email address, and password. Select I agree to the terms of service and privacy policy checkbox. Click Create Account. Once the sign-up is done, you can get the unique API key on your personal page. Once the account is created, use the username and password to log in and generate the API key. Next, we will be logging into the training org and create a REST connection. For that, you need to log in to the Informatica Cloud org using your credentials. For using the REST connectors, you need to have the REST connector enabled for your org. To enable the connector, hover over Configure, Add-on Connectors. Scroll down to find if the REST connector is enabled. If not, then add the connector. Now, to create a REST connection, go to Configure and click Connections from the drop-down. To create a new connection, click New. Enter the connection name as OpenWeather REST Demo. Select the type as REST from the drop-down menu. Then, select your runtime environment. Enter the base URL. Check Is Base URL Dynamic checkbox. Fill up the URL request parameters, form request parameters, and the header request parameters in the respective fields if you want to pass these parameters to the REST connection. If there are more than one parameters of a particular type, then you need to separate them by a semicolon. In this demonstration, we will be entering the parameters as Q is equal to city name, say London, and APPID key, which we created in the beginning of this session. Select Application JSON as the media type. select the request type as GET. If you select Basic Auth or Digest Auth as authentication type, the auth user ID and the auth password are required to be filled. Else, if you select OAuth as the authentication type, you must provide the consumer key, consumer secret token, and token secret in the respective OAuth fields. Also, if there are some more parameters which need to be passed for your OAuth, you must fill in those parameters in the additional Custom OAuth Parameters field. This field is essentially used for blue-green use case. In this demonstration, we will use the authentication type as NoAuth, so we don't need to fill the auth user ID, password, and the OAuth fields. In the config file or private key file name field, enter the name of the config file or the private key file in case you want to specify the default properties for the connection. For this demo, we keep this field as blank. Sample response XML or JSON file is optional. In case you want to generate the default response when you do not receive any response after the task is executed, then provide the full path of the sample XML or the JSON response file. Leave this field blank for the demonstration. Enter the response folder path. If you want the response to be written to a file in the path, use a local directory path. If you intend to provide with a list of parameters in the URL, form, or header, you can do so by creating different config files for them, and then provide the path to the respective files in the URL input parameters config file name, form input parameters config file name, and header input parameters config file name. These three fields are optional. In the Create the config CSV file field, select Yes. Then, test the connection. A success message will appear. If the test is successful, then change the Create the config CSV file to No. Click OK to save this connection. After creating a connection, you will now create a data synchronization task. The DSS task will consume the REST web services and will write the data to a flat file. To create a new data synchronization task, go to the task wizards and select Data Synchronization. Click New. Name the task as REST Get Weather by City Demonstration. Select the operation as Insert. Click Next. Now, you need to configure the source. In the source connection, choose your REST connection, that is OpenWeather REST Demo. Select source type as single. Select source object as JSON root. Click Next. Now configure the target. In the connection field, choose Flat Files. Click Create Target. Select all fields in the target column and name the file as weatherbicitydemo.csv. Click OK. Click Next. Now, we need to add the data filters. This will help filter the results based on the input provided by the filter condition. To configure the data filters, click New. Select JSON root from the drop-down menu for the object field. In the Filter by Field drop-down menu, select FLT-URL Input Parameters Config File Path. Select the operator as equals. Enter path to the input file defined previously. Click OK. Click Next. In the Field Mappings menu, to map the fields automatically, click the Auto-Match button. Validate the mapping by clicking the Validate button. A message will appear saying that the mapping is valid. Save and run the task. In the Activity Monitor, the task status will be displayed, and once the task gets completed, it will jump to the activity log. This concludes the demonstration on utilizing the Informatica Cloud REST connector to call a web service using the REST API. We now have a new REST API connector in Informatica Cloud as REST v2 connector. To know more about this connector, please contact Informatica Global Support. You are now ready to take the lab on the REST API. In this lab, you will create a REST connection using the REST connector. You'll create a DSS task to consume the RESTful Open Weather service. You'll get the JSON message and write that to a flat file. Let us now see a business scenario. A leading media group needs to report to a large group of subscribers daily. The information needs to be as authentic and as real-time as possible. In providing customers with the various latest updates according to their preferences, the company faced some major challenges. Amongst the various domains of media content such as sports, politics, electronics gadgets, etc., there were problems with the timely, clean, and authentic updates being fetched from different sources. The average time needed to meet all the requirements was sometimes as large as 24 hours, which decreased the credibility of the updates. So in order to establish the subscribers' trust and to enhance the user group's experience, they needed an alternative to their present system. The organization used Informatica Cloud's REST connector as a solution for data collection and integration related to various media contents. The REST connector helped to integrate data from various REST API-based applications. These applications were both external and internal to their present application. This easy integration of on-premise and external data using the REST connector helped them in updating and informing their subscribers with the latest updates of their choice as soon as possible. Hence, each subscriber is now served with the media reports from the area of their interest within few minutes with complete reliability from the sources. This ultimately resulted in multifold expansion of the user groups. This concludes Module 4. In this module, we discussed the types of web services supported in Informatica Cloud Platform with focus on the RESTful web services, used the REST connector, compared JSON and XML, and created a DSS that connects to OpenWeather via the RESTful web services and returns data.